Kirkle Math. Welcome back, ladies and gentlemen. We are here, 4.1. We're going to start multiplying fractions. So we just reviewed how to add and subtract them, and now we're going to review how to multiply. Multiplying fractions is easier than adding or subtraction, in my opinion, because we do not have to have a common denominator. And the biggest, most difficult part, I think, is just using that GCF to simplify. And to divide and reduce those fractions. Okay, so first we're going to review some vocabulary here. So here we have our fraction. It's just a pizza, and we've got 3 out of 4 slices left. Remember that top number, let's see if I can move it. Shoop. Okay, is a numerator, and the numerator is telling me how many equal parts we have. So we have 3 parts available. And that bottom number is our denominator, and it is telling me how many parts the entire whole is divided into. And we need to know the difference between numerator and denominator, because when we multiply our numerators together and our denominators together. So that is important for us to know, so make sure you have those vocabulary words down. All right, here we go into our notes. So like I said before, we are basically, when you multiply fractions, you're just going to go straight across. Numerator times numerator and denominator times denominator. No need to worry about common denominators. No need to worry about anything unless it's a mixed number, which I will show you later. All right, so here are our steps. Step 1 is just multiply straight across, right? Numerator by numerator, denominator by denominator, and then we will simplify if needed. So we're going to start here with our example problem. So we are going to do 6/8 times 3/4. So another quick reminder, this dot symbol here means the same thing as multiplication. So dot is the same thing as a multiplication sign. So we need to remember that. And like I said, we're doing numerator times numerator and denominator times denominator. So we're just multiplying straight across. Okay, so make a little note in your notes here. Multiply across. Okay, so we're going to do 6 times 3, which is 18, and 8 times 4, which is 24. Okay, and that's it. The last thing we have to do is just simplify. So if you've got 2 numbers, 18 and 24, and we're going to divide them by the GCF. So we're dividing the GCF of the numerator and the denominator. That is what we're doing. Okay, so if you don't know what goes into 18 and 24 evenly, you could start with 2, but we should know that 3 does go into both of these evenly. So if I divide by 3, I'm going to get 6 and 8. Oh, that's not the greatest common factor. Let's go again. I could divide by 2 this time, which means that both had both were divisible by 6. And I'm going to go in, let's see, 3/4. And that is our answer, 3/4. Okay, simple, easy, just like that. So we're going to practice. Okay, so we have 1/6 times 3/5, 3/7 times 2/3, and 7/10 times 8/21. So we're going to do these. I'll do one with you, and then if you want to pause and do the rest on your own, we can do that. But basically, remember, we're multiplying straight across. So 3 times 1 is 3. 6 times 5 is 30. I'm now going to reduce or simplify. 3 and 30 have a GCF of 3. So that's going to be 1/10. Okay, so these get to be a little bit easier, a little bit faster, but again, it just depends on the numbers you're using. And again, the trickiest part, I think, is just simplifying, which you have been practicing before, and we're just going to continue practicing here. So multiply straight across and then simplify. So take a break and then come back and check your answers with us. And there we go. All right, so number 3 was pretty simple. We got 6/21, we divided by 3 and got 2/7. And then number 5 was a little bit trickier. So I decided to find my GCF using prime factorization like we learned previously. in Module 2 because 210 is just a really big number, and I didn't know off the top of my head what went into it evenly. I could have divided both by 2 and then divided again, which would have ended up by being 7. But if you wanted to get the GCF and just divide in one big swoop, I made my 2-factor trees. I found the numbers they had in common, which was 2 and 7, and those are the numbers I multiplied together for GCF. Remember, if it was least common multiple, I'd multiply all of these numbers in here. But for this, in this case, I'm just going to multiply the ones in the middle of my Venn diagram, and I got 14. So I divided 56 by 14. I know that these two extra numbers would be my leftover when multiplied together. That's 4. And divide 210, same thing. 3 times 5 is 15, and I got 4/15. Okay, so like I said, those are pretty simple and straightforward. The hardest part is that reducing and simplifying, which you just have to practice and find that GCF. All right, so now we're going to throw in some numbers that are possibly greater than 1. So we're going to do a little bit of visualizing here. So go ahead and do this with me if you have your notes. If you don't have your notes, you can do this on just another sheet of paper. Just draw the boxes as I have them here. We're going to start by dividing this box into thirds vertically, and I'm going to shade in one of those thirds. Then over here, I'm going to change colors just to help us visualize. I'm going to divide these into fifths, and this can be hard. You're drawing 4 lines. And even as possible. See, I didn't really get it very well. Let me try that again. Let's try that again. Let's go a little bit shorter here. 1, 2, 3, 4. It's a little bit better. So these are my fifths, and I'm going to shade 3 of them. 1, 2, 3. And when I'm multiplying these together, because what we're doing is we're visualizing, right? What does 1/3 times 3/5 really mean? Okay, I have a third and I have 3/5. And what it's really telling me is how many times can 3/5 go into 1/3. That's really what my multiplication question is. I want to know what 1/3 of 3/5 is. Those are really what we're asking ourselves. But that can be hard to visualize when we're dealing with fractions because they're not whole numbers. And I don't know how many times 3/5 goes into 1/3 because they're not evenly split. So when we do this visually to show you what's going on when we're multiplying, what we're going to do is actually evenly split our fractions by taking 1/3 here and dividing the same box into our 3/5. Okay, and then I'm going to shade 3 of them. And what you see is the sections that are double shaded, those are the ones that become my answer. 3/5 of this 1/3 is actually 3 out of 15 because I have 15 total divided, right? There's 15 total shapes here, and only 3 of the 15 are double shaded. So it's 3 sections of this 1/3 section of the 3/15. And then if I simplify that, it turns into 1/5 of my entire box. Okay? That's how we visually represent this. And what you might notice is that every time that we multiply a proper fraction, a fraction with the numerator smaller than the denominator, by another proper fraction, you're going to get a smaller fraction. It seems weird because in elementary school we were always taught that multiplying means to make bigger, but with fractions, you're trying to find 1/3 of 3/5. And so you're basically dividing those 3/5 into 3 equal pieces and then counting how many of the total pieces. But you're always going to get a smaller fraction when you're multiplying proper fractions times another proper fraction. Now, when I'm multiplying a proper fraction times a whole number, that becomes a different story. What I'm really trying to do is find, again, 1/4 of 2 wholes. So there's a couple ways I could do it. I could draw 2 wholes and find 1/4 of those 2 wholes. Or I'm trying to figure out how many times 2 goes into 1/4. So what I'm going to do is divide this into 4 pieces, okay? And I basically want to figure out 2 groups of 1/4. 2 groups of 1/4. So here's one group of 1/4, and here's another group of 1/4. So my answer becomes 2/4 or 1/2. Now, if I'm doing this our algorithm way, remember that whenever we have a whole number, we must put it over 1. That is super important. Okay, it is a little fact that we should write on our notes here. Yeah. All right, so right here, go ahead and write this little note down. This is very important. If you are multiplying a whole number by a fraction, the whole number always has a denominator of 1, okay? And that's going to help us remember to multiply correctly, because if I don't put that denominator of 1, I might multiply the 1 and the 4 by 2, which is wrong. I want to multiply across numerator by numerator, and I need to give that whole number a denominator. Okay, so if I'm doing it the traditional algorithm way, I'm going to get the same answer, 2/4, which when I simplify by dividing by the GCF, you get 1/2. Okay, now what you might notice is that a proper fraction times a whole number is going to give you a bigger fraction than what you started with, because I'm working with groups of these fractions, so I'm making them bigger. It's more similar to regular multiplication where I'm making groups of a number, so I'm going to make it bigger. So as long as you are doing a proper fraction times a whole number, you're going to get a smaller fraction than that original fraction you're multiplying by. So let's practice. Okay. So I've got here 5/8 times 24. I have to put my whole number over 1. And now I'm just multiplying numerator by numerator and denominator by denominator. So 5 times 24. Okay, and I might have to do that over here. Let's see, 5 times 4 is 20. 10 plus 2 is 12. So 120 over 8 times 1 is 8. Okay, and now I have to figure out how to simplify this. So I do know 2 goes into them evenly, so let's start there. This is going to be 60 over 4. Oh, I can go by 2's again. 30 by 2. I can do 2's again. So 8 went in evenly. And that's going to be 15 total. So my answer is just 15. Okay. All right, pause for a second and do these other ones. Remember, when you have this mixed number, though, that you need to turn it improper first. You need to multiply your denominator times your whole number and add that remainder on top. So take a pause, try these 2 problems on your own, and then come back and see how you did. All right, here we are. So for number 10, I put my 8 over 1, multiplied across, and then reduced, and I got 2 2/3. And then for number 12, there we go. I did 10 times 3 plus 7 to get 37/10. Put my 7 over 1, multiplied, and reduced and got 25 9/10 as my final answer here. Okay. All right. So we're going to just practice a little bit more. You got mixed numbers, proper numbers, things like that. We're going to practice one more time. Remember, for these mixed numbers, to turn them improper first and then multiply across. It's going to save you a lot of time and energy. And then pop back in and see if you got them right. And here we go. So our first one's easy. It's 5/16, and we don't have any reducing to do. Number 2 ends up being 1/3 once we reduce by 15. Number 4, we get 19/8 times 16 over 1, and you end up getting 38 even. And then number 5, you get 9/5 times 5/12, and you get 3/4 even. Okay, here you go. So that is a great way to do multiplication. Just multiply straight across and then reduce or simplify. Give it a try and let me know if you have any questions. I'll see you in the next one.